Last section. Okay, we're still doing growth and decay. Okay, we're just going to look at the last part. Okay, part 4. Okay, so in that formula, same formula we've been seeing all week, y equals ab to the x. Anybody remember, I think we talked about this yesterday, when a is greater than 0 and b is a fraction. I remember we had the term proper fraction on the board. Anybody remember what we called this? It was exponential decay. All right, so anytime that this is between 0 and 1, it's decay. What about if b is bigger than 1? That's exponential growth. Okay? Okay, so now today we're going to look at the graph of exponential decay a little bit more. What happens when a graph decays? As you go to the right, does the graph go up?
It's like losing all your money.
So which way does the graph go? Up or down?
Down.
It goes down. It curves down. What about exponential growth? Exponential growth, just to show you, that's growth. It goes up. Decay goes down.
Yeah.
It's a tree.
All right, so what we're going to do is we're going to write a formula for something that's growing or decaying, but we're going to do it a little differently. I'm going to give you a picture, okay? Just like that. Does everybody already have example 1 printed on their notes?
Yeah.
Okay. So we're going to go through the steps. How do you figure out the formula? As long as you know 2 points, okay? I'm always going to label 2 points on the graph. Right. Is there any coordinate there that you think is going to be really, well, they're both helpful, but one of them actually already tells us something. Yeah, this coordinate tells us something. Does anybody remember in the formula, when x is 0, what's this number? That's the a. So we already know one of the numbers in the formula. Okay, and we're going to write that down right now. Okay, so steps to write an exponential formula or equation from a graph. Okay, so the first thing we want to write down is what kind of exponential is it? Is it growth or is it decay? If it's going up, growth. If it's going down, decay. So if you look at this one, this is exponential growth. So I'm just going to write that in. This problem is growth. Next thing we need is the formula. Exponential growth and exponential decay use the same formula. How does the formula start? Yep. Y equals AB and X as the exponent. In that formula, what are the 2 letters you have to figure out? 2 of them you don't, and 2 of them you do. Which ones? A and B you do have to figure out, or you don't? You do. Okay, we have to figure out the A and the B. Okay, so any questions on why this one is growth or why that's the formula? All right. So which one do you want to do first? Do you want to find A first or B first? A. Okay, so we'll find A first. It's a good choice because that's what I already had in my notes. So to find A, you're going to look, I got to scroll back up for a second. You're going to look at this point right here. Anybody remember what you call that point where it crosses the x-axis or y-axis? It's the y-intercept. So you're going to look at the y-intercept. and you're going to plug in the y-intercept. Okay, so if I scroll back up for a second, in this problem, what's my y-intercept? I just circled it. It's kind of hard to see, but it's 10. Okay, your y-intercept is 10. You're going to plug in that number for A. Right, so let's start with that. So I got 10. Do I know B?
No.
No, I don't know B yet. I need to figure it out. Okay, that's going to be the next thing I do. Since I don't know what it is, I'm just going to leave it as B right now. Okay, is there anything else that they gave me in that picture that I haven't used yet? Let's go back up for a second. Is there anything else in that picture we haven't used? Jordan? So we used that one, the one I circled. We already used that. But is there something else that we haven't used? The 12 and the 1. We haven't used the 1 and the 12 yet. What do you call this? That thing I just wrote. Josh? It's a coordinate. What's the first number in the coordinate? It's always that's an x. What's the second number in the coordinate? It's a y. So, we have A. We're going to use the other coordinate. What's the other coordinate? I just copied it down right here for you. 112. And in our problem, we're going to plug in 1 for x. Look at the coordinate. X is 1. And we're going to plug in 12 for y. So after you do this step, you should only have one letter left. Okay, can somebody tell me where... Where's the y going to go? Where does that get plugged in? Kyle? Which side? The left side, yeah. So y equals, we already plugged in A. We don't know B, but there's one other letter I know. X. And what's x in this case? X is 1. Now we're going to solve that for B. What's b to the first power? B. Okay.
Anything written to the first power is this.
12 equals 10b. So b to the first power is just b. And now I have one step left. How do I get b by itself? So if we had something like this, then we could subtract 10. We have to divide by 10. Okay? Because that's how you cancel multiplication. Okay? Divide by 10 and divide by 10. So what's b? Let's see. So what do you get for b? No one knows? Well, what's on the left-hand side? And then we have to reduce it. So what do you get when you reduce that? Let's leave it as a fraction. That's okay. Yeah, 6 over 5.
What you reduce by, Antonio? What number did you use? 2. Okay.
Right. So now we've got A. What was A? 10. What's B? B is 6 over 5. Right? So now what's the final answer? What would be our equation? Yep, that's a good start. Y equals.
12 times 6.
What are the two letters you're plugging in for? And what's A? To A is 10. What's B? 6 over 5. So there's no 12 in the final answer. A is not 12, B is not 12. So we're not gonna use that. So A is 10, and B was 6 over 5. Okay, so your first step, you found the 10. The next step, you have to use the coordinate they gave you to then find B. Okay, so we'll try another one of those. Does everybody have step 4? Okay, so remember in step 4, you just fill in for A and B. Your final answer should always have an X and a Y in it. Okay, look at that one. Okay, what's our first step? Step 1 is to figure out if this is what or what? Growth or decay. Which one is this? This is decay. So I'm just going to write below it exponential decay. What are the two letters I need to find? Derek, can you tell me one of the letters you got to find? A. Yep. What's the other one? B. So I'm just going to write down A and B. One of those letters we can get very quickly right away. We don't have to do any work. Which letter is basically given to me? A. What's A in this case? Remember, you look at that X, just like if you had a table. You look at where the 0 is, and then look at what number is with it. Okay, so A is 8. But I still need B. Can somebody remind me what's the formula we use again? Y equals A times B to the X. How many letters in this formula do I know? Technically, I know more than that. How many letters do we know? Okay, which ones do you think we know? All right, what's the A? Okay, so we know the A is 8. We got that. What other letter do we know? Yep, we know the Y. And what's the Y? No, 0 is an X. 8, nope, we already used that. That's A. 4. 4 is the Y. Is there anything else that I know? Still something there I haven't used. We used this. The 0 told us that what A was. So the 0 and the 8, this is done. The 1, what's the 1? That's an X value. So we're going to plug that in right there. Okay, what's B to the first power? B. And now how do we get B by itself? Divide by 8. Divide by 8. So what do we get for B? 1/2. So we got B. We've got A. What's the final answer? Josh? 8 times 1/2. And then to the X. Perfect. That's your formula. Any question on that one? Okay, what if you had a coordinate given to you like this? 0, 6. Okay, I'm not going to draw a picture. Let's just say that you had a coordinate that was 0, 6. And another coordinate that was -1. It doesn't really matter. -1, 8. How would you find the equation for that? If you had a picture, you could figure out if it was growth or decay. Don't worry about that part. What's the next letter you can figure out? Yeah? Yeah, very good. You can figure out A. What's A in this case? 6. Perfect. So you've used this. A is the number that's with the 0. Okay, I got A. What else do I need? B, what's the formula that I use for that? And how many letters am I going to be able to fill in right there? More than 2? 3. What 3 letters can I fill in? All right, Y. Let's start with that. What's Y? Y is 8. What's A? 6? B, I don't know. What's X? -1. Okay, we've seen that before. What's happening here when you have a negative exponent? How do we deal with that? Anyone remember how we deal with that negative exponent? Well, what don't we like about that exponent? That it's what?
Negative.
Negative, so fix it. How do you fix a negative exponent? Okay. You can make it a fraction. And you flip it. So where is the b going to go?
The bottom.
This goes to the bottom. Okay, I'm showing you that because that might happen on the test. So now you have that. Instead of having the b right next to the 6, you put it in the bottom. What happens to the exponent when you move it to the bottom?
Becomes positive.
Becomes positive. Yep.
So why did you get rid of the 1 completely?
Oh, you can leave it, but what's b to the first power? It's just b. So anything to the first power is just itself. All right, now we have 2 steps left to solve that. How could you put this b on the other side? Because I would rather put it over here than have it on the right side. Yeah, what do you multiply by? To move just the b. Multiply by b. If you want to cancel out a denominator, you just multiply by what's in the bottom. What happens on the right? Those are gone. What's b times 8? Yeah, normally we write that as 8b. And now your last step, how do you get b by itself? Divide by 8. Divide by 8. And then from there, I'll let you finish it. You just have to reduce that. Yeah, so b, we could write it. b would equal 3/4. Yep. So now you have b, you have a, you could write your final answer. Any questions on what to do if b is a negative? If b is a positive, it's easier. But if b is a negative one, you got to be able to do what we just did right there. Okay. All right, so this is the formula for exponential decay. Did anybody see a difference between this and growth? There's only one thing that's different.
There's the minus sign.
That's the only thing that's different, right there. There's a minus sign instead of a plus. Everything stands for the same thing. A is your initial amount. T is your time. R is your percent. It's your rate. And how do we always write percents when you plug them in?
Guys, make sure you write this equation down so you have room for it on your reference sheet. You have the arrows, because
Put the arrow on the wrong line on your paper.
So what do you do when you plug in a rate? It's always plugged in as a decimal. Yep. Okay, so you throw a plus in there, it's growth. You put a minus in there, then it's decay.
now, guys, I mean, obviously we don't have a word problem up on the board right now, but how will we know which formula to use? What might be a key word in the problem to tell us whether it's going to be growth or decay? Decrease, right? So decrease, are we going to use this formula or the other one we talked about, the one we did the warm-up on? This one, right? If the word decrease or decreases is in the word problem, you want to use this. If it says increases, then you want to use the other one with the plus. That's the only difference. Okay, son?
Does everybody have what's in yellow?
Not yet. I'll put it now.
Okay, so the last problem says the number of acres of pine forest decreased from 1963 to 2002 by 0.5% every year. In 1963, there were 41 million acres of forest. So first, let's write a formula for that. Okay, so part A on the test would say something like, write a formula to describe what's happening up above. Okay, can anybody tell me a number in here that's important and what it would be in the formula? Josh? What's 41 million? What's that going to be? Yeah, we're going to start off with 41 million acres. I'm going to write 41, but just remember that when we do this, 41 represents million. Okay? What's going to go next to the parenthesis? 1, then minus. Now be careful. What's my percent here? 0.5%. So how do we fix that so we can use it? 0.005. Any question on why that's your rate? I need one more thing. I need t. Where's t going to go? It's going to go as my exponent. Do I fill anything in for t? Do I know how many years have gone by? Like, did they say, find out how much forest would be left after 7 years? No. So for now, that's all I do. Okay, let's, I want to figure out how much forest would be left in, somebody pick a year between 1963 and 2002. 1999. Okay. So part B. How much forest is left by 1999? What do you have to know? What do you have to figure out? There's a letter in the formula you have to know. Natalie, do you know what letter we have to figure out? T. Yeah, we got to figure out T. So we started in 1963. We want to know how many years have gone by since 1963 to the year I just underlined. How do you figure that out? How do you figure that out, Si?
I want to know the difference.
Well, pretend someone was born in 1963. How would they figure out how old they are in 1999?
Subtract.
Subtract, exactly.
Outside.
So take 1999 and subtract, so 36.
Make sure you do the more recent year first.
So is 36 the answer? Is that it? 36? It's what? 36 is the time. So that's what you're going to fill in. 41. Let's do this out. 1 minus 0.0005, I'm going to type that in. 1 minus 0.005, 0.995. Okay. Now, somebody tell me, how do I type that in on the calculator? Start with 41, okay? Parenthesis. 0.995. Yep. Yep, press the exponent. 36. So how many acres of forest are going to be left in 1999? And if we round it to 1 decimal place, what would it be? 34.2 what? No, not 34.2 acres, 34.2 million acres. So remember that 41 wasn't 41 acres, it was 41 million.
You were about to say million.
No, 34.2 million, was it in acres? Okay, so that's assuming we lose the same amount of forest exactly every single year.
And guys, we might, like the one we did in the warm-up today, we might just tell you to just express it, just write it out. We won't tell you the number of years. You can just put X or T. That's why I said all week, just make sure you pay attention to the directions. Because you may not have to solve it, you might just have to set it up.
And if we ask you to just set it up, yeah, you should simplify. So I didn't do that here, but I did it down below. What was 1 minus 0.005? 0.995. If you don't do this on the test, I'm going to take probably 1 point off. So just make sure you do the subtraction. Okay, questions on that one? All right, I think that's it. So homework tonight is part 4 on 6364. This was our last homework, last day of new material. Last test of the quarter, tomorrow.
Last test, no, not last test, we have the final.
Final exam, June 9th.
Guys, listen, can you go back up a little bit? We're going to give you guys tomorrow in class, when you finish the final, stop moving stuff and listen. We are going to give you the reference sheet for the final exam tomorrow. All right? It's going to be just like the midterm. How did we do the reference sheet for the midterm? Somebody remind me.
It was annoying. You had to look through
Huh?
your notes.
You had to go back into the notes, or if you don't have your notes, where could you go?
YouTube.
Math with Hager, right? Look up the example. Write the example down and write all the work. Any little notes we made on there, make sure you write them down as well. All right? Also, on the reference sheet, there may be a spot where Mr. Hager and I say, go back to the notes from this section and copy down these steps. So you have the steps so you know what to do. All right? We're going to give it to you tomorrow. You have a whole sharp week, and then academic Monday and academic Tuesday to get it done. Now that next academic Monday, we're reminding you guys all week, we don't have class. Your reference sheet is going to be due at the end of class on Tuesday. That academic Tuesday. That way, I know you guys. Mr. Hager, I know you guys. You may forget about overshot week. All right? So, but understand that it's probably going to take more than just a class period to get it all filled out. So start working on it over shop week. I'm not saying you have to do the whole thing over shop week, but get a little bit done so you have enough time to finish the rest in class on Tuesday.